Hello, guys. Yeah, I hope really that you really had a good lunch, as me. So I'm going to talk about Ratpack. How many guys of you guys have already heard of Ratpack before? 3, 4, 5. Okay. So this is not going to be too deep talk because still not many people know about that. But I hope I will show you some interesting stuff closer to the end. So and you will probably also see why Ratpack is a good fit for microservices, especially if you take word micro very literally, because you can create very small stuff with Ratpack. Okay, a few words about me first. So my name is Andrey. I'm Java and Groovy developer. I do a lot of automation as well, so some people actually may call me a DevOps guy. But I'm still a developer and I still develop applications, mostly in Groovy, mostly in Java. I'm co-author of Groovy 2 Cookbook. And I'm organizing a community back in my town, which is Riga, Latvia, in the Baltics, called Latcraft, Latvian Craftsmanship Community, Software Craftsmanship Community, and I organize a conference that is organized by the same community called Devternity, which is going to be in December. But enough about me. Yeah, you can find my connection details on the slides later on, which I'm going to share that. But let's start talking about Ratpack. Or first of all, let's talk about microservices and why Ratpack may be a good fit as well. So that's how microservices are defined by James Lewis and Martin Fowler. So in short, microservice architecture style is an approach to developing a single application as a suite of small services, each running on its own process and communicating with lightweight mechanism, often an HTTP resource API. Makes sense, right? And that's what most of people do actually when they mean microservices. And Ratpack is really a quick start in that sense because you can really write a small script which will be just enough to have a fully functional application. But before you do that, you have to have some requirements installed, and of course you have to install Java 8, and the thing is that Ratpack will not work on any other Java, well, probably on Java 9, of course, but all the legacy Java SDKs will not support Ratpack because Ratpack exclusively requires Java 8, so there's no legacy stuff there. And you will need Groovy, but it's kind of optional because Ratpack mostly the Ratpack API is totally based on Java 8, so you don't need Groovy per se, but Groovy actually may help a lot with even minimizing the syntax, improving the readability of the code much more. How many of you guys actually use Groovy? Nice, well, roughly half. And another optional component that you may also find useful when you create Ratpack applications is Gradle, because it has very nice integration with Ratpack and has a special plugin for Ratpack, which helps out with continuous deployment of the application. Okay, so if we use Groovy and if we use Java 8, well, we have to. The simplest thing we can do with the script to define our applications, the first 3 lines, we need those to grab the libraries. And for those of you who know Groovy, it's not a surprise. For those who don't, Groovy has a built-in mechanism for grabbing dependencies from Maven repositories, and you can write a script that will automatically grab dependencies from there. And then in that sense, script will be self-contained, so you don't need to write in a build tool. You just write them as an annotation, and you get the dependencies out there. So these are the 2 dependencies that are needed for Ratpack, which is Ratpack itself and the login framework. And then what you do, you just import the static method called Ratpack, and inside you could basically call that method, which allows you to combine several closures in a pipeline that forms an application. This is a completely full application that works, and that starts a web server which serves requests on the root and under the get method, under HTTP get method. So very quick start, and as you can imagine, you can of course get much more complex than that. Otherwise, it would be not very useful. After you have these 8 lines and these 3 lines, you can save them in the file, and that's pretty much enough to start Ratpack. Of course, because it's a Groovy implementation of Ratpack, you have to use Groovy to start it, and that's how you do it. No, very simple. I can actually show you how it looks like a small demo, so you know that I'm not lying. And Actually, I will just copy it from here. So I will have these lines. I will create ratpack.groovy. I will copy, oops, sorry. I will copy it here. And the next slide is I'll copy these lines here. I'll copy them here. So now I just do start groovy and ratpack.groovy. And here I go. So it started on by default, the port is 5050. And we can directly access that here. So the time is 13:13. Well, actually, it's a cool time, elite time. Okay. Anyway, so yeah, that's very easy. But that's probably not the most interesting part. Before we jump into more complex stuff, let's try to go through facts about what Ratpack actually is and what's behind that. So the name Ratpack comes from this group of people, and probably those of you who lived in the US or know more US culture than this group of people, like Frank Sinatra and some others, they were named Ratpack back in the days. And basically the name comes also from that, because Ratpack initially was based on the ideas present in Ruby framework called Sinatra. So Ratpack kind of expanded on them, and they was created as a successor. But in Java Groovy ecosystem, of course. So Ratpack basically is a combination of several Java libraries, but it's very lightweight, so it doesn't include too many libraries, and it's very lightweight, and in that sense that it doesn't put a lot of opinionated decisions on you. You can pretty much decide what you want and use the libraries that you need, but at the same time it gives very lightweight framework that allows to combine very nice HTTP applications. So as I mentioned, it was inspired by Sinatra, which was originally a Ruby framework. It requires Java 8, so no legacy stuff. It doesn't require a container, so we already saw that. You just need a simple Java runtime and nothing else. It doesn't implement servlet API, so it doesn't have this legacy, and there is a reason for that. The main reason for that is because servlet API is very thread-based and kind of not its request model is thread-based, and that's not a good thing. And I will explain why in a while. And it's open source and free, so you can use it right away. The core is very minimal and it's based on very few abstractions. The main abstraction is handler. It also has a registry with all the components, and also recently they added another expression called service. Handler is basically something in the middle between a servlet filter and servlet itself. Registry is a dependency injection context, which is available to all the handlers. And service is an asynchronous or non-blocking service which provides promises to handlers and all that stuff. Ratpack is extensible and has a lot of modules on top of that. And of course, you only need the main core to start with, but you can always expand it with additional modules, or you can write your own module. So the typical Ratpack application would look like this. So you will have Ratpack core, some Ratpack modules on top of that. Behind the scenes, by default, Ratpack is using Juice as a dependency injection mechanism, and it uses Netty as a networking mechanism, providing all the HTTP magic behind the scenes. And then on top of that, you can add all your favorite libraries that you want, Hibernate, whatnot, and use them in together. So it's very lightweight and simple in that sense. Also, it's very alive and active, so it's a very evolving code base. They do releases quite often. The first came out around 2012, and since 2014, as you would see, they pretty much do release every 1 or 2 months. So now they are on the last release will now go to 23rd, which is 1.4.1. And stable release 1.0, which was a very huge milestone for the Ratpack team, was reached last year in September. So it's already 1 year old, like the 1.0 is 1 year old and stable. Also commit history, if you look at that, it's very active. A lot of commits are happening from especially since 2013, 2014. A lot of activity. A lot of stars, like 1,200 stars, which is quite impressive for any open source project, no matter what it is. Code base is mostly Java, with some Groovy libraries on top of them. A lot of contributors, a lot of releases already, and a lot of commits. So it's very active in that sense. This is the core team, which is composed of 7 people. And yeah, I met all of them. Good guys. And actually, one of the reasons probably why it's called Ratpack is probably because of these guys, because they're really rock stars. Yes. Talking about the modules, it has many. So there was a presentation already about RxJava, and there is a module for RxJava that integrates with Ratpack. There's a Pack4j for security, Gradle for building, different database, session management, all that stuff. Because by default, in Ratpack, you don't have session support, but you can inject it as a module and use it. And that makes total sense, because it's not in every application you actually need sessions. Also, JSON parsing, dependency injection. By default, Ratpack is using Juice, but you can also use Spring Boot if you want, if you prefer that, if you're more familiar with Spring way of doing things. Templating, and testing is also very powerful in Ratpack, because of the lightweight nature of Ratpack. You can actually start the full application within your unit test or acceptance test and test it very fast. You don't need to deploy it anywhere. You can just use unit test to do that. As I mentioned already, it's Java 8. The API, the full core is written in Java 8, so you don't need Groovy if you don't want to. But there is no reason to not do that, because it has very good support for Groovy. Plus, the performance actually is not an option. It's not an issue with this combination, especially because they use a lot of static compilation behind the scenes, and also the IDEs have some help with that. And of course, for Groovy support, I would definitely recommend using IntelliJ IDEA. Eclipse, unfortunately, has very poor Groovy support, pretty much dead by now. NetBeans I haven't tried, but IntelliJ works very well for me, especially with the Ratpack APIs and Java 8 APIs combined together. It's very nice. Okay, let's try to dive a bit deeper. So handlers, as I mentioned already, handler is the core of a processing pipeline of a Ratpack application, and handler is something in between the servlet and servlet filter. And the chain is composed of handlers, and when the request is coming into the Ratpack application, basically it comes from one handler to another handler until some handler will actually produce a response. Compared to, let's say, Servlet API, where this chain of filters and servlets, it's kind of static. You can't really change it without redeploying application. In Ratpack, the handler chain is dynamic, so if you need that, you can inject some parts of the chain later in the process, depending on what's coming in. That's roughly how it happens. So request comes in. We have a handler with some global objects available, which is global registry, which is global dependency injection context that gives us all the services, all our dependencies, and it can go further and also can extend the context while request is going through the chain, and definitely use the objects later on in the chain. So chain can enrich the context that is being passed. So this is something similar to the request object that you see in the servlet APIs, but at the same time, it's much more powerful. So, and as soon as some handler has an ability to reply, we send a response. If no, we go to the next handler until we reach the end of the chain. If at that point nobody is serving the request, Ratpack returns an error. Okay, let's write some more code. You already saw the date server, which I wrote very quickly. So yeah, this is what already launched. But that's a very simple thing. So of course, we don't want frameworks to write things like that. We would like to write something more involved in that. And I will just show you the code. Sorry. So this is more, this is a bigger application in Ratpack, but again, it all fits in one script, roughly 84 lines, which implements more methods on top of that. So if we look at the Ratpack code, here we have the configuration of the dependency injection context, which may inject our services and all that stuff. And we can inject modules, we can inject individual instances of services, and this all happens here. So the configuration part. Then inside the handlers, we can define our handlers responding to certain methods, certain paths, certain content types, and define some sort of logic inside. So in this first, let's say we would like to write the first version of our data API, and we would like to return to make our customers happy. We would like to return different formats, and that's what we can do in this way, which is probably not the best way, but as a first version, it could work. So we're using we're serving the JSON path to return JSON, and as you see here, what happens is that behind the scenes, Ratpack has a set of renderers, and we give a JSON object to the renderer, and behind the scenes, it's making a JSON response. The same happens with XML. It also has a default renderer for XML. We can return markup in Groovy format, and it will return automatically the XML data in the response. Yes? Yes, it's part of the path. In this case, it's part of the path. I'll just show you how it works. So I run this server. Come on. Usually it's faster. Yeah. So this is the date server that I started. If I go here, so I see that JSON path is defined, and it obviously returns JSON. If I go XML, I get XML. If I type HTML, I get nice HTML. And this all happens inside here. So because we're passing JSON structure to the renderer, to the render method, which basically is returning the response. This is the final method in the chain. And because when the request was going through the chain, it found this JSON path is handled by the get method, and it entered the closure here and returned the response. The same happens in XML and in HTML. And in case of HTML, we're just using Groovy templates, which are very much like JSP pages. And we inject some data inside the templates. And I can show you them here. So the template looks like this. This is a Groovy template, but it's like very much easy readable. Okay. So let's imagine that at some point we decided to write a new version for our API, and for that reason we defined a new namespace called v2, and we can actually just use the prefix method to actually hide that part, and all the handlers that are going inside that prefix will obviously have the prefix also on the path. And as you see, it's very easy to read because it's quite logical what happens. And in our version 2 of API, we actually wanted to be more RESTful, how to say, and instead of having the path serving different types of the content types, we decided to use content type as a distinguisher for our handle chain. So in this case, we say that we expect post request, and if the content type that is passed to our post request is application JSON, then we render JSON. If it's the same path, but we get XML as a type. So some of the types are defined as variables, as additional methods. So if it's XML, then we get to XML. If it's plain text, then it's plain text. If it's no match, then we get unknown format. So very easy to route content depending on methods, content types, and other stuff. And another good thing is that any part of this handle chain can be extracted into a single class and separate class, and we can combine many handle chains in this way. So in that sense, I very like Ratpack, because the starting point is very easy to start. You can always start with a script, but then you can start refactoring that into more components, and this naturally will evolve into better code base eventually. Of course, we don't want to put everything here. We want to eventually refactor it to more classes. But we can always start with a single one. And for testing the version 2 of the API, I had to write the curl commands because I can't really pass, well, I can, but it's not going to be so obvious. Do the same in the browser. So what I do is just do a simple test on the v2 and setting the header with the content type, and I just get that. So I get XML, JSON, and plain text as a result of curl. Any questions at this point? No. Okay. So yeah, just to summarize that, you can create your handler chains by using prefixes. Inside those, you can use handlers for methods, and you can also specify parameters if you want, and you can refer to them using path tokens. You can do by method routing if you want. So you can handle the same path with different methods and do it like that. You can also do by content, like we saw already in the date server example. You can also serve static content if you want. And yeah, you can also use templates like we saw with the plain text and HTML, and inject variables instead. So it's kind of easy, but at the same time, I guess you probably don't really you don't really see the benefits yet, because that's kind of basic web framework part, and that's not what Ratpack is good for, because that's easy part, that's nice part, that's very concise and easy to start, but at the same time, that's not the best part of Ratpack. Yeah, templating is easy. Another thing that is actually easy is testing. And Ratpack provides several ways of testing applications. Of course, you can always use something like Selenium, because yeah, it's easy to, especially if it's a real web app. If it's an API, then of course you can use something like curl or just plain HTTP client. But also Ratpack provides internal components to actually start the full application or part of the application with some part of the handler chain inside a unit test or inside an acceptance test, and run that against the real HTTP server and test more real stuff than you probably expect. I will show you later on the acceptance test part, but let's just show me the Geb part. Geb is a Selenium wrapper. Do you see it? Maybe I should put it here. So again, our date server was one script, and I can run another. I can write another script, which is going to be Geb Selenium wrapper that will test my API over against the Selenium. So two scripts. So as I mentioned, I can start very simple. One script for the application, one script for the testing, which is very handy in the beginning. Yeah, I can just run it, test API, to show you that it works. And behind the scenes, it will now start Phantom.js, and we'll actually go to the application and test it. Okay. Well, that part actually means that it succeeded. Okay. Let's go further. Let's go to more complex examples. Let's build some services, because of course nobody would want really. Well, it's not really useful to build date servers like that. You probably want something more complex, and let's build something like that. Well, imagine we have an internet shop which sells some products, and in a monolithic applications, you would probably do all things inside the same web app, which makes sense for small apps. But if you're leaning towards microservice architecture, then probably you would split that into more services. And that's how I offer to split that one. So we have a front web application which serves our web internet shop, and we have a review service, which probably is implemented by a different team, which like using web Elasticsearch or some other data storage for that, and we don't care. We really care about the service itself. And another one is the booking service, which is also probably handled by a different team, integrates with different payment gateways and stuff like that. And yeah, we have one team focusing on this, another team focusing on that, another team focusing on that. But of course, initially, someone should write the first code, and all of them could be actually Ratpack. And at this point, of course, we need to probably go away from just single script. We need to start more realistic project. And for that purpose, I would suggest using something like Lazybones. Lazybones is a tool, templating tool, which has some templates for pre-made Gradle projects, Maven projects, and all of that stuff. And it also has a template for Ratpack. So the easy way to create it is just say create, the name of the template is Ratpack, and then the project name. I can show you how it works. So we can create something like that. Lazybones create Ratpack. Do you see it? So that's what I did. And it generated a full Gradle project with all the plugins, all the base setup for my date server in this case. And I want to create three services. So I actually pre-created them already. I have shopfront, and I have booking server, and I have review server. So and I used Gradle to generate the idea project for me. I can start it up now, and you'll probably see it. Where are you? Shopfront. Yeah, here it is. So as in the case of simple script, we have a Ratpack.GUI, which is the central entry point for our handler chain, and we have some services that are building on top of that. So we're injecting the booking service, we're injecting the review service, and they are available inside the handlers. And the way the dependency injection works is that we can actually specify them in the closure as parameters, and that's it. We don't need to call anything else. And then they will be available inside the whole chain here, and we can call them. And this is where actually interesting part in Ratpack starts, because Ratpack has actually two thread pools. One for serving incoming requests, another one for serving blocking requests. And it's always advised, or it's actually a rule, to have the blocking requests being captured into blocking blocks, like blocking on and blocking up. And then Ratpack will offload that code block into a different thread pool, leaving the main thread pool, the request processing thread pool, to serving new requests. And this is well, to me, it's the best part of Ratpack, because it offers performance, and it offers also deterministic execution model for blocking and unblocking requests. And by default, all things that are inside Ratpack and implemented in Ratpack, they are non-blocking. Another nice thing of Ratpack is that it implements Promise API. It has its own Promise API, and that's what actually I think that's missing in Java 8 in general. The Promise API that Ratpack provides is very nice and concise, because here we don't see any promises being created, because they are being passed from one to another. So actually this blocking up, the one that in this case is calling the review servicing and constructing the book array, it's returning a promise. And the promise is processed then when the promise is completed, when we have the data, then we have this then block that is executed when we have the data. And this block is already executed on the request processing queue and rendering the stuff, not before that. So it's not visible here, but actually this is highly concurrent code, which uses two different thread pools. But Ratpack execution model makes it's much easier to write than if you would use something else like your own thread pools and stuff like that. Okay, I'll show you what happens now. So now we have shop front, and I can start shop front from IntelliJ, just by running it. And the way it works, the magic here actually is that we run a Gradle build, but we run it in a continuous mode. If you guys you haven't used continuous mode in Gradle, you should try, because it's a killer feature. Now it's running and constantly checking on the changes in the source code, in the static files, and whenever something changes, it automatically redeploys them. And that magic is done by Gradle. So if I do some change now, whatever it is, maybe I should do it like that, println. Gradle will automatically redeploy it. And as you see, redeployment is like 1 second, and it's quite fast. So now I can go to my front shop. And this is my front shop. So as you see, it responded. It showed me the catalog, but it didn't show me the reviews, the review rating, because it should have get them from review service. And review service is not running now, which I can start now and see that actually something is returned. So this is one. Let me show you. So I have, this booking service, and I need the review service. Review service. Which again is exactly the same project, but with some different implementation, different API. I can run it. And it's also, I also started it in continuous mode. So all the changes I do to this project will also be populated automatically. So now I started that. Yep. Well, the first time, of course, it built everything, so it took a bit more time to start. But every next change will be faster because it's only uploading the updated stuff. Yes, I'll go to. I reload this. Okay, doesn't want to work. Demo effect. Is it really working? Oh, sorry, I started the booking server. I didn't start the review server. Obviously, it doesn't work. This one should be. And at this point, the review service implementation is very dumb, just returning random number. But as you can imagine, it can be, of course, expanded to real data storage in the background. But as you see, my front application, it didn't fail. It didn't complain that that another service is not available. It just responded with some default values. And this is one of the ways you can split, first of all, the responsibility between the teams. So one is responsible for front, another one is responsible for review servers. But also you can have some built-in mechanisms that will control that some of the dependencies are down, we are not complaining, we're just returning some default behavior. And in this case, we get 0 as default behavior. And when we started the review service, we get some data back. And yeah, because it's random number, every time I refresh, it's getting new stuff. Of course, if I kill my review server now, then I get zeros back. And because it actually getting timeouts, and it combines the collection then for each of the 5 books. Of course, it's when the other server is down, we still see this down part, slow part on the front server. So ideally, what we should do with our shop front is in our review service. This is the implementation of the review service. So very simple, just calling the UI. The HTTP API, but what would we do is that we could write something like that. If, let's say, connection exception, whatever it is, then we could let's say set the circuit breaker a flag, initially it's going to be false. Circuit broken. Oh, broken. So ideally, how the truly resilient application should behave, is that it sets the flag that if something is bad, we set the flag to true, and if not, circuit broken, then we actually execute the code. If it is, if it's not, if it is broken, then we return some default value faster. And this case is going to be promise, I think, return 0 as double. So, and in this case, it actually should, because the other server is down. Oh, sorry. I'm missing my. First time is probably going to be slow because it's waiting, but the second time, because it set the flag, it should be faster because now the circuit is broken and it doesn't request the server on the other side, unless I made a compilation error somewhere, which it could be. Okay, I probably made a mistake in my code somewhere. But I hope you got the idea. And the thing is that, of course, you don't want to implement this kind of things yourself. There are mechanisms to do that already. And one of the libraries that is also integrated in Ratpack is called Hystrix, or Hystrix, I'm not sure how to pronounce it, which implements the circuit breaker mechanism, and you can inject it into your Ratpack services and be very resilient and fail safe in that sense, and combine many services in the way. And Ratpack has everything for that. Ratpack has libraries and integrations and examples of how to do that. Any questions on that? Okay, how much time do I have? 10 minutes, okay. Oh. I'll go back to slides now. Yeah, and another thing of any kind of microservices that you really have to think of operational aspects of that services, so they are easily deployable, easily packageable, easily restartable, and all that stuff. And Ratpack can, with the help of Gradle and some other tools, actually gives that possibility. So you can create, you don't need WAR file, you can just create a fat jar file with all the dependencies, or you can create tar and zip using the Gradle application plugin. You can also create dep and RPM packages, which probably will be more operations friendly. Sysadmins usually prefer deploying dep files or RPM files instead of jars and tars. And it's easy to integrate that kind of pipeline into configuration management tools and provisioning tools, which are there. Also integrated into Docker if you want, if you're using that in production. This is how if you're using some provision tools like Puppet, you can define the deployment of with book and service, something like that, with some data inside, with the jar file built from a repository, from Git repository, and being deployed to being exposed as a service. So we can do it like that. So the examples here. Yeah, that's how I did it a couple of times. So just exposing the Git repository somewhere and defining the contents of the Git repository, the Gradle build as a command for the service to run my Ratpack service as an operating system service and have an ability to restart it if I need. And of course, you can combine it with different other options like Chef and Ansible, and also the services like service discovery and configuration management services like etcd and console, Eureka. They all are very well integrated. They should be very well integratable with this kind of flow, especially if you have services that have to start on demand or have to start independently of each other. And Docker obviously is another way to do that. Also, I would like to show you a bit of Hystrix demo. So, and of course, you want to have, but before, just to summarize, now of course, I showed you like a set of free services, actually mostly two of them, but of course, when it grows bigger, you would probably appreciate the conciseness of Ratpack in general, and but it should not, of course, be the Ratpack itself. It could be, some of the services could be implemented with other mechanisms like, I don't know, PHP even, or Node.js, whatever, but Ratpack would be a good start for services developed within the same team or with the Java teams, and it's a very good library to do that. And let me show you the Hystrix example. So the circuit breaker, I will use another application which is a demo, which is an example application from Ratpack team themselves. I have it here. So again, the flow is very simple. I just start the run task from Gradle build, which is integrated directly into IntelliJ. And it starts application and continues the build in continuous mode, so the flow is the same. And now I should also start the Hystrix dashboard to show you that stuff is going on. Can I have it here? Hystrix dashboard. Just give it a sec. What? Sorry. Okay, probably still my date server is still running. I need to kill it. I need this one. So now basically start two applications. One is an examples book. Another one is a Hystrix dashboard, which aggregates health circuit breaker data from the examples book. Let me see if it's working. Okay. So this is the examples book application, and I can sign in there. And this is the Hystrix dashboard for which aggregates streams from the application. Oh, let me show you. Oh, sorry, guys. Was Hystrix stream? So now it shows the circuit breakers from the application. Now it's only one, and it's called getAll, which basically is called when we populate the first page of the books interface. So, and because it's doing nothing at the moment, there's only one request was going on. I will, if I start now a test on top of that, if I run like 100 requests in 10 threads, you will see that that this circuit breaker is starting to show something. So it shows the statistics coming in of incoming requests, and it also shows how many of them are in this case. And the good part of this circuit breaker is that if the other part is down, we can define the behavior, what to do. We can either return default value, or we can make other stuff to fail, or other circuit breakers to break, and this is very handy in terms of microservice architectures in general. Okay. So, yeah, the main takeaways from this presentation, I hope, are that Ratpack can be used very quickly to prototype web APIs and applications, and learning curve is really small, and it's really easy to start, and there's not much to actually to think about. It's not only easy to read and easy to write. It's also very high performance, especially given the execution model that it implements, offloading different types of requests, threads on different thread pools, and in nature it is non-blocking by default. And also it doesn't lock you in with the opinionated libraries. You can always bring your own library and use it on top of Ratpack or inside Ratpack for anything you want. So it's very easy and lightweight in that sense. Okay, there's some reading material you can find. There's also a book that was released this year by Dan Woods, who is one of the Ratpack team members. Yes, and if you feel like doing that, please contribute to Ratpack in case of in form of documentation or code, or whatever you want. And yeah, I think I'm done. That's it. Yes.
One question. I'm in an environment where we do have a lot of web services, SOAP stuff.
Mm-hmm.
So if I'm handed a WSDL and say, "Oh, implement that," how would I go about that in Ratpack?
Well, there are now definitely now ready-made solutions to expose the VSDL as it is, but you can definitely do some workarounds if you want, but not the ready-made solution.
How about load balancing between several of these web services, or is that something else?
Well, it's not part of Ratpack, but since it's HTTP, it's quite easy to implement HTTP load balancer on top of that. And it depends whether you want like using to use sessions or not to use sessions. Because if it's stateless HTTP application, then it's just round robin. If it's session based, then sticky sessions and stuff like that. But it's pretty basic HTTP stuff, so it's not part of the framework, but and for that reason as well. Okay, thank you guys.
Yep.
And there's a voting device there, so please, well, press the green button, obviously.